guys, it's Miss Carlson again. Today we're going to move on to the next unit, and that is going to be covered in Chapter 4 of your textbook, and it is an introduction to atomic structure. So make sure you have a notebook sheet of paper or a Cornell note template to take good Cornell notes, and we're going to go ahead and get started. So the first thing I want to do is just define exactly what an atom is. And it's helpful to look at a picture of an atom in order to understand what it's made up of. And over here is kind of what you should visualize when you're thinking of an atom. You have the electron cloud, which contains one of its subatomic particles known as the electrons. You have the nucleus, where you can see is made up of these little tinier particles, protons and neutrons. And they call it the nucleus because it is the center. Now, atoms are the smallest piece of matter that still retains the property of an element. So we say an element is the smallest pure substance made up of a particular type of atom. So this picture here is actually a scanning electron microscope showing you the presence of an atom, since we cannot visually see atoms with our eyes. Again, we use a lot of these models like this picture here to help us visualize what an atom actually is because it is so small. Now, there are 3 subatomic particles, as I mentioned, that make up the atomic structure. And they are the proton, and its mass is indicated here, 1.67 times 10 to the negative 24th, so grams, and that is very, 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 very small, as you can possibly imagine. Its charge is a positive 1. So I want you to try to think P for positive, and that's what proton starts with, and it has a positive charge. I also want you to take note of and remember that its location is in the nucleus of the atom, in the center, like I showed you in that picture in the slide before. Now, keep in mind the neutrons are also in the nucleus, and notice that they each both have similar mass sizes. So, between the proton and neutron, they make up the mass of the atom and are located in the nucleus together. Now take a look at the electrons. The electrons, notice, are 9.1093 times 10 to the negative 28th. So because of this right here, even though this 9 makes it seem like the electrons might be bigger than the protons and neutrons, you got to take into account how many placeholders back you got to go. And electrons are much smaller than a proton and a neutron. Either way, they're all very tiny. Now, the electrons are negatively charged. And a lot of students get confused that neutrons are negatively charged because neutron starts with N. However, neutron, you want to be thinking of neutral because neutrons have no charge. Okay? So that part gets kind of tricky, but if you can remember neutron, neutral, no charge, the only thing left is the electron, which is, you maybe think of it as being electrical and having that negative charge. And again, as I showed you before in the picture, they are just surrounding the nucleus of the atom, just kind of floating around in their own little cloud, and we'll kind of get more into that structure here shortly. Okay, some important terms you need to be aware of in helping you identify an element, as well as identify how many protons and neutrons are in a particular element. So the first one we want to talk about is the atomic number. The atomic number is the number of protons that are in an atom, and the number of protons is what makes an element unique, or an atom of an element unique, because that proton number determines what that element is. Now, the mass number is the next one that we want to talk about. And remember, I told you that protons and neutrons were found in the nucleus, and they have more mass than the electrons. So they have so much more mass than the electrons, despite how small it is, that the electrons don't even take into account the mass of the entire atom itself. It's just the protons plus the neutrons that make up the mass, or also referred to as the atomic mass of the atom. So you can actually calculate the number of neutrons by looking up the mass number and the atomic number. You won't find the number of neutrons listed on the periodic table. Usually you're going to get your mass number and your atomic number on there to locate an element, and then you would actually have to subtract the two to get your actual number of neutrons. Sometimes it is the same as the number of protons and electrons. A lot of times it may not be, especially when you get to the larger or the more massive elements. Alright, the last thing we're going to talk about is isotope. And an isotope is when you have the atom of the same element that has a different number of neutrons. And I am going to attempt to draw you. And that piece of fruit I'm going to draw is a watermelon. So this is a slice of watermelon. Here's another slice of watermelon. For that I'm going to draw my seeds in black like they normally would be. So this watermelon is going to have 1, 2, 3, 4, 5 seeds in it. This piece of watermelon only has 3. Now just because this piece of watermelon has 5 seeds and this one has 3 doesn't make either one of them less a piece of watermelon. They're both still pieces of watermelon. One just happens to have 5 seeds, one just happens to have 3. I want you to think of the same idea when you're thinking of an isotope of an element. Let's just say one atom of carbon has 6 neutrons and one atom of carbon has 8 neutrons. They're both still an atom of carbon, just one has a different number of neutrons than the other. Alright, and that's where we're going to leave off today, just making sure we have a crucial understanding of those 3 subatomic particles, and then what some of these numbers represent that you're going to be able to identify an atom of an element with on the periodic table. Please go back and replay anything that you need to see again, and make sure you take good notes, and I'll see you again next time.